Hi everyone, back for another video. This time gonna do basics of oval setups, sort of going behind the principles of oval setups and what makes them different from road setups. Just some of the basic things that you need to know before really jumping headfirst into it. So the first thing I'll mention is if you haven't watched my basic setup parameters video, um, even though it was a mostly road geared video, there are like 80% of the concepts transfer back and forth, if not all of them. So I would recommend, um, watching that first. And one big reason I want you to watch it is because I covered this section, this aero um, configuration section and the aero calculator section. I don't go specifically through the speedway options, but I go through enough to where you would be able to do it. And I do show some graphics of the actual different speedway options look like and what they are. So it's pretty interesting, I thought, and also I just show you how to use the aero calculator and which is really basic but really important to setting up this car, especially on super speedways where because at super speedway, especially a place like Indy, we're doing 220, 230 mile an hour average lap speeds. Aero is really critical. So, especially aero generated from the floor. So, ride height's really important here. So, and so is drag, more so than a road course. Um, so yeah. Um, so one big thing I'm gonna get into, obviously on a road course, you basically have two ends of the car is how you treat the car. You have the rear and the front, and you don't really care about each individual corner. I mean, you do when you're looking at a particular corner on the track, but when you're looking at it from a setup perspective, you generally have a symmetric setup, and so you're not looking at it per corner um, yeah, there's no reason to. But on an oval, you truly do have four corners that you're setting up. You can notice, even though this is the fixed setup, I mean, every corner has um, different values for all the different setup parameters. So um, the first thing that I'll sort of cover is cross weight. So you can see in the garage here under nose weight there is a value for cross weight. And so basically all cross weight in the garage is describing is how much weight is on the right front, left rear diagonal compared to how much is on the left front, right rear diagonal. So the two diagonals of the car. You can see from the corner weights that the right front and left rear in this setup have more weight. That diagonal has more combined weight than the left front, right rear diagonal. This means that you have less cross weight, which basically is going to end up resulting in the car understeering more. So more negative crossweight is understeer, more positive crossweight is oversteer. And so crossweight is a good way on ovals to change the mechanical balance of the car. So yeah, it's a good way to do that. But there's no specific crossweight value to aim for. It depends on the track and what other setup parameters you have. But I've had setups that are near max crossweight, and then some setups that are near minimum crossweight, and then and a bunch of setups, in between, almost all in between. So, really just depends on what all your other settings are and all that stuff. So, yeah, I'm going to go through every corner of the car and describe sort of what changing the ride height of each corner will do, because I think that'll sort of help give a better understanding of how everything works. So, yeah, so the main things that I'm going to focus on are ride height in terms of aero, and then also aero balance and cross weight. Those are the two most important things. There are other considerations as well, such as your left to right side right height balance, and then there's also things like whether you're grounding or not. Obviously, if you lower the car too much to where it'll ground, then you'll probably get some pretty weird behavior. I'm just going to ignore that when I'm going over these descriptions and assume you're not going to ground. So yeah, so I'll start on the right front. The right side I always find is pretty intuitive, because typically the right side is going to do whatever you think it would on a road course. So because that's the loaded side, it's a lot more intuitive, and pretty much on the left side, everything on the left side is kind of backwards. So basically, so if you lower the right front right height, as you can see, we're going to take weight off the right front, and this means that more weight is going to shift to the left front right rear diagonal, and this means that the cross weight value is going to go up. So that means you see it went from negative 139, I think, to negative 131. This means you're going to get more mechanical oversteer just from lowering the right front. It also, another factor to consider is you've also now lowered the right front right height, which means that you're going to be making more downforce from the front of the floor and the front wing, which means that you're also going to get a little bit more front grip from that. So you're going to slightly change your aero balance and your crossweight balance. So you can see here, like if I set these to, let's just say something with a normal amount of rake, then if I lower, you see when I lower the front, I increase front downforce percentage. So, and one thing to notice here, with the road course package, we saw that lowering the front just kept improving efficiency. You can see here, at least with this step 3 front wing and the long wheelbase, which we'll talk about in a second, this is actually, it gets less efficient. You keep making more front downforce, but you're proportionally making more front drag, if that makes sense. So yeah, lowering the front's going to keep making more front downforce, but yeah, you're also going to introduce more aero drag. So obviously it's a balance, but yeah, so basically lowering the right front will make the car rotate better mechanically and aero-wise. The right rear is similar, so raising the right front, well, I'll do lower for all the corners, so that way it'll be consistent. So lowering the right rear, lowering the right rear will take weight off the right rear, and you can see our cross weight went back down to minus 138, so it'll cause more understeer from that perspective, and it'll also you're also lowering the rake of the car when you do this. So as we talked about in the last video, rake is sort of the right height difference between the front and rear. And whenever you reduce rake, normally that's going to cause more understeer because you're shifting the aero balance forward. So see, when I reduce the rear right height, the front, I'm going less front downforce, so that means they're going to have more understeer from aero. And then, like I said, you're reducing cross weight, so that's going to cause more understeer mechanically as well. The left side is mixed, so you can see that if let me go down on all of them to be consistent. If I go down on the left rear, it has the same effect on cross weight as the right front did, which makes sense because they're on the same diagonal. So it'll make the car mechanically more oversteery. Sorry, see, I went up on cross weight. So it'll make the car mechanically more oversteery, but aero-wise, it'll make the car a little bit more understeery because you have less rake and a little bit more rear downforce compared to front. Right front or left front similarly. So on the left front, if I lower it, I'm going to decrease cross weight, and basically that's going to make it so that the car is going to be more understeery mechanically, but more oversteery aero-wise. And so basically you can always, so you don't have to memorize these things, even though you will memorize it after you do enough changes, but all you have to do is do what I've been doing. You can look at, okay, what happens to the crossweight when I go down, and what happens to the front downforce percentage when I go down. And then that tells you what the car is doing mechanically and aero-wise in basic terms. And of course, this is a reminder that these ride heights here, I covered this in the other video, but these ride heights here are at speed, so you have to get these from telemetry in whatever part of the car, whatever part of the track you care about. So if you're looking at downforce in the corners, then you should probably take ride heights from the corners, and if you're trying to get like drag from the straight or something, you should probably look at your ride heights on the straight. That's another thing to really consider when you get more advanced into super speedway setups. What you're trying to do is, there's always a compromise, right? Obviously on the straights you want minimal drag in an ideal world, and in the corners you want to make the most efficient downforce you can. You still don't want to have a lot of drag on the big ovals because drag in the corners does matter a little bit, but yeah, you still you want to make downforce from the floor so that or you just want to have downforce in general, right? So on a short oval, it's different. On a short oval, typically it's like a oval combined with a road setup. Like aero-wise, in a lot of ways, it's a road course setup because you really at most short tracks, especially the flat short tracks, you really don't care about drag that much. I mean, you do, but for the most part, you don't. And you're going max downforce, and you're just looking to keep up momentum through downforce in the corners. So, but on a big super speedway, anytime you're running the super speedway aero kit, you care about drag for the most part, except for maybe there's some 1.5 miles, like Kentucky, I guess old Kentucky now, we're going to start calling it. That's a lot flatter. Might be, you care a little bit more about downforce there, but, yeah, anywhere where you're spending a lot of time on the straights, like especially the 2 mile and 2.5 mile ovals, you really care about drag a lot. So, yeah, so, so that's sort of what the ride heights do. Another thing that's obviously important is your spring rates. So the spring rates do the same thing that I covered in the last video and more in depth. Basically, softer spring rates have more mechanical grip, but the stiffer you go, you have the advantage of more ride height control. So, and ride height control obviously is important to aero platform, because theoretically for aerodynamic performance, you would want perfectly flat ride height curves, and you would want to keep them at the optimal point, right, to produce the most efficient downforce. But then obviously there's a trade-off with mechanical grip. So next we'll go into spring rates, which are sort of the next most important thing. In general, there's a couple of things that are the same to road setups. So if you increase the overall stiffness in the front, you're going to get more mechanical understeer. If you increase the overall stiffness of the rear, you're going to get more mechanical oversteer. Um, and, basically a softer spring on a particular corner will offer more mechanical grip, but you're making a sacrifice at having a worse or more variations in ride height, which, typically cause a worse aero platform. Um, at least less consistent aero platform. However, like I was sort of talking about before, there's a combination of, you want to adjust your spring so that you're getting certain, ride heights in the straight that minimize drag, and then, you want a little bit different ride heights in the corner once you get roll and weight transfer, um, that are more optimal for producing downforce. So, you sort of have to play around with the different spring rates to get different dynamic ride heights and different weight shifts. So, but at least, in a general trend, the springs on the right side are just the same as a road course, so they're very intuitive. The stiffer your right front spring, the more understeer you're going to have mechanically, and the stiffer right rear spring, the more oversteer you're going to have mechanically. So yeah, the right side is, intuitive. The left side is sort of the opposite. So obviously there's that overall rear and overall front stiffness I was talking about, but um, the softer the left rear is, the more oversteer you're going to get, and the softer the left front is, the more understeer you're going to get. So sort of the left front does the opposite from the right front, and the left rear does the opposite of the right rear. Basically, the easy way to remember it is the things on the same diagonals do the same thing. It just depends, so it kind of depends on what you want. So let's say you have an oversteer condition, and you want to dial some understeer into it, So I have several options. So if I want more understeer, I can soften the right rear or left front, stiffen the left rear or right front. I can lower the left front or right rear, and I can raise the right front or left rear. Sort of the way I would go about this is I would look first at telemetry, and I would look at my ride heights. So if, just from experience, I know roughly at least where I want, especially where I want my right sides to be on a race set. And you can probably get a good idea from looking at the aero calculator where you want them to be. But basically, if I already have ride heights roughly where I want on the right side, then I'll start thinking about a couple things. So if I have good stability off the corner, then I would feel comfortable being able to put more rake into it. So one thing to note here is so raising the left rear would mechanically help my understeer, at least on corner entry, and mid corner. But one thing I've noticed is because you have more rake and you have a higher roll center, then I found that typically with a higher rake, you tend to get more exit instability. So while I found that raising the left rear will do that sort of, and lowering the left front would also do the same thing. So basically if I have good stability on exit, maybe I would try doing one of those two things, especially if the left rear or left front are not really where I want them to be ride height wise. spring rate wise, I would consider a couple things. So one thing is, you also want to manage your tire split. Typically, the tire wear split, sorry. Typically, the stiffer end of the car is going to wear more. Um, so if I have oversteer, like I was saying, and but I don't have a huge tire wear issue in the rear, then I'm probably not going to soften the rear springs. I'm going to look more at cross weight, basically. I mean, of course, eventually, if you have an oversteer condition, you're going to overheat the right rear and slide it too much. But like, let's say it's a little bit oversteery, but I'm not really sliding it that much. I'm not really burning it off. Like, I think if I reduce the sliding, I don't really burn it off, right? If that makes sense. Then I'm going to look at, um, I'm not going to care as much about softening the right rear. I'm just going to try taking out some cross weight. A couple other things to mention here is to help you make these decisions, you can use your in-car tools. So another big thing I would do if I was trying to decide, so I have an oversteer condition, I can try two things. I can try actually I can try three things. I can try going negative weight jacker. So this is another thing I haven't talked about yet, but the weight jacker is an in-car tool that allows you to basically adjust your right rear ride height. It basically jacks up and down the right rear to change cross weight. Um, of course, it also changes rake and your rear ride height and all that stuff. Well, technically all your ride heights a little bit, but especially your right rear and left front ride height. But when I go down on the weight jacker, you can see that it goes more negative, the cross weight, and I also lower the rear from 065 to 053. And one thing to note is in order to pass, tech in the garage, I have to have weight jacker set to 0. But obviously you don't have to necessarily start or run it at 0. You could go out of the garage and start at -2 or whatever. But so I can go more negative weight jacker in the car to see if it's a crossweight issue. You just have to keep in mind that while you're changing crossweight, you're also changing rake a little bit. But typically that's sort of my go-to, for in terms of that. The other way to tell is with your ARBs. If it's possible, if you have an oversteer condition, you could stiffen your front ARB or soften your rear ARB. So with this setup, by default, apparently you start at 5.2. You can either go to 6.2, 6 on the front bar, or 1 on the rear bar, and that sort of that's going to change your roll stiffness, which would be kind of what you were doing if you were changing your spring rate affects roll stiffness. So if I end up deciding that a stiffer front bar felt better, maybe it's better to stiffen the right front spring, right? And if crossweight didn't help, then and it's probably not a crossweight issue, like if weight jacker didn't help. At least this is for fixing balance issues. One thing that I've had bite me before that you need to be careful of is this hasn't happened to me on a race set, because typically you're not running the right rear this close to the ground, but especially on like cold tires, especially there's a few tracks I think, anytime where you're running low rake, you have to be careful to not go too negative on crossweight or on your weight jacker, sorry, because as you can see, you're lowering the right rear ride height, and if your right rear is already pretty low, you can just ground the right rear of the car, and this will obviously have the opposite effect. When your right rear is just completely, like if you just took away your right rear tire, you would spin, and that's sort of what happens when you just ground the right rear, you at that point you have low friction. You're just going against the floor instead of having as much tire grip, and you just spin. So sometimes people get confused, like, why do I spin when I go more negative weight jacker? It's because you're grounding. And you can see it in telemetry. If you open telemetry, the right height will be in the ground or whatever. So um, that's one thing just to watch out for. So yeah, I would definitely, play with ARBs and play with your weight jacker to see if your balance is helped by either one, and then that you can sort of use that as a setup direction guide in a lot of cases. Um, a couple other things. So the cambers on the right side pretty much work the same as road course. You're gonna look at the inside and middle tire temps and wear on the right side, and the idea is you want to maximize contact patch in the corner. One thing to note is that compared to a road course, you're going to have much more even temperature and wear on the right side of the car compared to a road course. Like on the road course, it's going to be mostly inside and middle. The outside temperature and wear is going to be pretty close to the inside and middle most of the time on oval. This especially is true at any track where you have a long duration corner and shorter straights. Because you're constantly loading it, right? So you should be on that full contact patch a lot. How we read these might change a little bit with the new tire model. I'm doing this pre-new tire model, but hopefully it will be the same in that you're mostly still looking at the inside middle and you do care about the outside a little bit. Then for the left side, most of your temperature and wear is always going to be in the outside and middle. And you're going to, because you have positive camber, so you have reverse camber, because basically the tires are going to lean the opposite way in the corner. Well, they're going to lean the same way as the right side, but basically you don't have cambers pointing against each other. You have cambers slanted together on an oval setup. Like if you were to look at it from the back of the car, the tires are angled parallel to each other. And this is because obviously you don't care about, on a road setup, they're asymmetrical. They're pointing against each other because when you roll to the right-hand corner, the left-hand tires are now upright, and when you go through a left-hand corner, your right side tires are upright. So in this, because we're only going one direction, you can have all of your tires upright in the corner. That's sort of the goal, or mostly upright. You do want typically a little bit of extra camber. Well, it just depends on the situation, but especially on the left side, which has less load, and the tires are a hard enough compound where you can afford normally to have them not upright and basically take advantage of camber thrust. And camber thrust, without going too much detail, is basically like basically when you have a little bit more camber when the tire is not upright, you're using the sidewall stiffness of the tire to help push the car through the corner. I would have to draw a force diagram and everything, but you can look up articles on it if you're really interested. But basically, yeah, so there is such thing as adding a little bit more camber than your wear and everything would suggest. That's why I was sort of saying I generally try to get the outside and middle temperatures and wear fairly even. And obviously this also balances in with pressures. If you have more middle temperature and wear, that could be too high of a pressure on the right, on, for example, say the right front, or it could be not enough right front camber. So it could be either one, just like on a road course. Basically, sort of the principles of tire pressure stay the same as how I covered in my basic setup parameters video. However, one difference is, especially for the left sides, because the left sides aren't as loaded, sometimes you don't feel as much of a difference. You do feel a difference with the left side pressures, but all of the pressures affect straight line speed, especially at a big oval like Indy. So if you can afford in the corners to get the tire pressures a little bit higher, everywhere, then that's going to help your straight line speed. Obviously, there's a balancing point. Too high is going to reduce mechanical grip to the point where you're suffering too much in the corners. But if you could somehow figure out a way to raise tire pressures, you're going to improve straight line speed due to rolling resistance, decreasing rolling resistance. But yeah, in terms of the tire pressures themselves, sort of the right front, right rear pressures work just the same as they would on a road course. The left sides are sort of backwards. Honestly, once I have the left side pressures set, I typically don't really mess with them that much because they just have they don't have really a very big, you have to make big changes to the left side to really feel anything balance wise. So really I more look at like the temperature and pressure distribution, like the left front versus left rear pressure, and then also, the temperature distribution across each tire to set the pressures. And then I might try overall stiffening, like increasing left side tire pressure or reducing left side tire pressure. And so sort of what that'll do is if I have the larger tire pressure split I have from left to right, typically the more it's going to cause the car to rotate through the corner. But obviously if I'm lowering the left side tire pressures, like I said, you're going to have more rolling resistance, so you're going to be a little bit slower in the straights. So, and then so I typically adjust the right sides for balance, and actually balance and wear, because also the right sides are the ones taking a beating in terms of wear. Sometimes on ovals, like I was saying on a road course, typically you can't feel a difference with a half with a half psi change, a one click tire pressure change. But on ovals, a lot of times I can, so I might just make a one or at most two click adjustment of tire pressure on the right side, and then see what happens. So it's a lot more sensitive. Yeah, and so one thing to note here that's different from a road course in relation to cambers and everything, and even tire pressure to a certain extent. If I raise the right front tire pressure, so let's see, my ride height was 0.934. When I raise it, it goes to 0.936. So typically I don't worry about this for small changes because you physically can't adjust it to the same value. But especially if I ever take big swings on the left side, you want to adjust your static ride heights to be the same and your static crossweight to be the same if you can. But when it comes to camber, so let's say I want to add more positive camber to the left side. And so camber does the same thing. Obviously on the right side it's the same. More negative will generate more heat and will lean the tire over more and wear the inside and middle more. On the left side it's the opposite. So you get in the trend like a lot of things on the left side are the opposite. So the camber on the left, increasing the value, will lean it more and will cause more temperature buildup and more toward the outside of the tire. So you're kind of just looking at the tire as a mirrored thing. But yeah, one thing to note is, so when I change, so let me go back to where it was. When I increase camber here, so my right height is 576 and my crossweight is minus 138. You see how, let me remember what my right height was, 076. You see how my right height changes? That's just because how the suspension geometry is. If I adjust the camber on the real life car, I need to change my pushrod length to get my right height back the same. So I'm going to adjust my right height back to the 576, and now I have at least the same right height, which I wanted. My crossweight has shifted slightly because of the camber change. So that's one thing to note. Most of the time, it's not going to cause a huge deal, but yeah. Um, so a couple other things here. Obviously, so there's no third springs on ovals, so these third spring gaps are meaningless. That's just a side note. So you're only dealing with corner springs. And one thing that's unique on ovals is, well, actually, there's a couple things here. So one thing is your steering offset. So because typically you're going to have toes that are opposite of each other, you're typically not going to have this. A lot of times you have something like this. I think it's this way. I always get confused. But basically your toes are pointing in, they're pointing parallel to each other, but in opposite directions or whatever. So, and also because your cambers and everything, basically the car is going to want to turn one way. And if you have a steering offset of 0, when you're going down the straight, your steering wheel won't actually be straight. So you have a steering offset to make the steering wheel straight or however you want it down the straightaway. So you can just play around with it to get it however you want, but more positive is I believe more positive is more to the right. Is more to the right, like putting the steering wheel to the right, and then more negative is putting the steering wheel more to the left. And really, that's just a driver preference thing that doesn't affect performance of the car at all. It just is. Some people like the steering wheel like to where you're pointing it a little bit to the right on straights, to where they're so that their hands are more upright in the corner because they feel like they have more control in that position. Other people like me, I tend to have the steering wheel pretty straight, play pretty flat on the straights, just because it feels more normal to me. It feels really weird to have a lot of steering angle in it, but like I said, it's a pure driving preference thing. One thing that's more of note here is, and it's also a thing on road courses, is steering pinions. So the more teeth you have, the faster your steering is. Basically, the faster your steering is, the more responsive, so the more the wheels will turn for a given rotation of the steering wheel. So more teeth here is going to cause the car to feel more twitchy to different steering inputs, and it's going to be a little harder to be smooth. So most of the time, I almost always run 6-tooth on ovals and 7, I believe, on road, 7 or 8, depending on the setup. And that's sort of the conventional thing. I think sometimes on short ovals, some people run 7-tooth, but I could be wrong on that. So the other big thing here is wheelbase. So basically, wheelbase is the distance between your front and rear axles. So you have two options. You have the 121 and the 119. 119 is less stable. So basically, if you think about it, it's a lot easier to rotate a tiny little go-kart with a really short wheelbase compared to, a big, well, even like lighter, like road cars. I mean, there's no road car as light as a go-kart, but it's sort of a similar thing. Basically, the shorter wheelbase you have, the easier it is to rotate the car. It's a little bit less stable. But, you also have more instability, so you'll notice, like, in the corners, the car reacts a lot more to your inputs. So, it's more on a knife edge, right? So you give it a little bit of throttle input, and it goes from understeer to oversteer. And it can be, a little bit more driving like a seesaw, either understeer, oversteer, and harder to find the in-between. And so larger wheelbase would be more stable. It also, the other thing that the longer wheelbase allows you to do is on tracks where your rear downforce is limited. So a good example is Texas. Well, actually, not Texas anymore. Michigan, where you're only allowed to run -6 rear wing and no rear wicker. You can't get any more rear downforce, but you can if you change the wheelbase. So with 119, my front downforce is 44.4. With 121, it basically it goes down by 1%. So I'm actually shifting the downforce rearward. The thing to point out though is that the downforce to drag ratio changes significantly. So it goes from 3.3 well, it goes to from 3.29 to 3.334. So you are hurting your efficiency quite a bit. That's a huge efficiency change. So yeah, you just sort of have to evaluate those options. I can guarantee you, because of the efficiency hit, the shorter wheelbase is basically always going to be faster in clean air. But if you're at a really downforce limited track, I guess it's possible. Um, I have found situations where we end up running longer wheelbase, but it really just depends on the scenario and everything. And yeah, even then it'd probably be like a really high temperature situation or something. Um, yeah, so that's sort of what the wheelbase does. It changes your aero balance and changes your how much stability the car is going to have overall. Um, sort of the main thing. And then this is another big thing I've seen on short ovals that's kind of interesting. It's your aero to crossweight balance, right? So how do you determine? One way is to just do it empirically, right? You can take out front wing or whatever, and then add in weight jacker or something like that to get more crossweight. But like, how do you determine what your so if you have a neutral car, right? How do you know if you have the right crossweight to aero split? So basically, what I'm saying is you could have more negative crossweight and then add front wing, right? Because you could increase your front downforce percentage and decrease your crossweight and get the same balance, but you're just changing your mechanical and aero balance. Basically, like I'm saying that because all the corners are the same speed on most ovals, you can have the car balanced for that corner, but for all you know, it could be understeering mechanically and oversteering um, aerodynamically. And one decent way to figure this out is, when you get in traffic, when you get air taken out front of your car, how much it's always going to understeer more because that's just the nature of losing overall downforce. But you can sort of get an idea of how it feels then. You can also, um, I guess, look at your tire wear splits. A lot of times that's a good indication of what it's doing mechanically. So if I have, typically on a super speedway, sorry, I'm jumping all around, but this is just how I am. If I have, in clean air, typically I want a little bit more right rear wear than right front wear. Maybe 5% on a full tank run. As long as it's stable, I want, roughly 5% more right rear wear, or something like that. So that when I get in traffic, the wear becomes even. And because you're inevitably going to understeer more in traffic and you're going to use the right front more. Um, if the car feels neutral to me and clean air, but I'm having more right rear wear, that probably means the chassis is too loose. Um, Likewise, the opposite's true. Um, Another thing I've noticed is that, like I was saying on short ovals, I did a little bit of a test. I think it was at Milwaukee. I basically found that the more front wing you add, basically the more front downforce percentage you add, and the more negative crossweight you have, typically the car will um, rotate better on turn-in. So with more oversteery aero, more understeery mechanical, it'll rotate more on turn-in, which sort of makes sense, at least especially on a short oval where your cornering speeds are a lot lower than your straight speeds, like your apex speed, like somewhere like Milwaukee where you're lifting, is a lot lower than your straight speed. So you're at the highest speed at corner entry. So you're going to have that more aero effect. So it's going to oversteer more. And then I found typically you feel the crossweight most on corner exit. Um, you get more over or more understeer on exit, I guess, with that setup. And then if you went more positive crossweight, less front wing, you would feel the rotation better, or more on exit and more understeer in entry. So that's sort of how that relationship works. Yeah, there's a ton of trade-offs like that, and if I go through all of them, this is going to be a really long video. And also, some of them I still don't understand. I'm not, frankly, I'm learning a lot of oval setups, and I've fairly decent knowledge base, and but there's still some areas that I'm not the strongest on. Um, like for example, I know I need to improve my knowledge on what how the left side works on oval sets in general, especially right height wise. So, and sort of what right heights I want on the left side. So, anyway, you know there's always more to learn, and yeah, that's sort of just some of the basics that I know. And one other thing I want to talk about is gearing. So, um, your gearing philosophy on oval is different. I haven't covered gears specifically in another video, but I will soon. I want to. But just briefly for your oval gearing. So typically, the convention is on a super speedway, first gear is for pit lane, and your considerations for first gear length are you don't want it to be too short, because if it's too short, you could get wheel spin on the apron exiting the pits, um, or on a restart. Those are the two things you need to be careful of, and I would test it. Ideally, you test it on cold tires and on worn tires to see, how bad it is. But you also don't want your first gear to be too long, because then you'll bog on the restart and you'll get a worse restart, right? Then your second and third gears are also just acceleration gears for the restart, so you just want them to be um, balanced out so you have roughly the same RPM, not the same, but you spend roughly the same amount of time in each gear, I guess is the way to describe it. Basically, you just want them all to be balanced so that you're hitting the right RPM spots. You're trying to stay in the power band for as long as possible, which I guess I'll go into more detail in a future video. And then your fourth gear is supposed to be sort of a mix. So your fourth gear is supposed to be long enough to where it's another acceleration gear in addition to third. So it's supposed to be roughly evenly spaced in terms of RPM drop with first, second, third, and fourth. But fourth gear also, you need to have it so that if you lose momentum in a corner, you can downshift to fourth. So basically what the philosophy is fifth gear is your clean air gear. At a track like Indy, most people in clean air, they're just running in fifth all the way around. Sixth gear you only use if you're in draft, which is a lot of the time. If you're in draft, or like if you're making a pass, or even if you're just regular, just in traffic, use it on the straights, and then you might go down to fifth or even fourth in the corners. And sort of like I was describing in my driver feedback video, if you can have a fourth gear that's long enough to use, it'll help you get rotation in the corners in dirty air, right? Um, and also it'll just keep you in the power band better, right? So it's good to have a usable fourth gear, especially when you get checked up and lose momentum. Like let's say you're trying to run the inside or something, trying to make an inside pass. Um, that's where you'd use a fourth gear. Some short ovals I have done like setups where I go down to third in traffic and I use fourth through sixth normally, but it just depends on what I need for accelerating on restarts and if that's even necessary, right? But a lot of times on short tracks, because the draft is not as significant, you just use like you get to like the middle of sixth in clean air, and then down to fourth in the corner, then up to fifth, up to sixth, middle of sixth, and then when you're in traffic, you just go to the top of sixth, and to where you just don't quite tack out, but sometimes you get close, and then you go down to fourth or maybe even third on some occasions, but not very often. Yeah, so that's sort of the oval gear philosophy. Um, And so basically what this is going to end up doing is your fourth, fifth, and sixth gears are going to be really close speed-wise. Like there's not going to be a big RPM drop between them. And then that's because you're really fine-tuning it based on what running speed what speed you're running at to try to stay in that power band. And you're basically trying to spend as much time as you can between like 11,400, 11,500 and 11,800 RPMs. Roughly that range is sort of the good spot to be in for a lot of the time. Basically, you want to be as high as RPM as you can, as long as you're not starting to get close to the limiter. So, yeah, that's just sort of a rule of thumb. Obviously, it depends on situation and everything. Yeah, so the thing I was saying about first gear and wheel spin for restarts and aprons and stuff, that is especially a thing on short ovals. That's critical. If you have too short of a first gear and you're having to really manage wheel spin, obviously you can either crash or it can just hurt your confidence, right? Just putting the power down. And, that can be a big deal. Crucial moments of the race, especially a short oval restarts, can be really important. So that's something really important to consider. So, all right, I think I've rambled enough. That's sort of basics of oval setup. I can go into more detail if people want or if there's interest. If you have questions, just feel free to ask me. I'm sure I messed up a couple details, but I'm pretty confident overall that 98% of what I said was correct. Try not to go into any details that I wasn't sure about. So that's why I may have been intentionally vague in a couple situations. Another reason I could have been intentionally vague was just to try to keep the video brief. So it's kind of both. But yeah, so yeah, like I said, I'll do another video on gearing probably, which is sort of a thing I know a lot about. But yeah, I hope you guys enjoyed it. Like I said, message me if you have questions, and yeah, feel free to reach out and also share the video if you know people that also will find it useful. So yeah, see you guys next time.